So in this first video of Unit 4, we're going to take a look at relations and functions. So let's first define what a relation is. A relation is the interaction between two variables. And the two variables are often called inputs and outputs. Those words should be familiar to you from Algebra 1 and geometry. And usually relations are displayed in one of four ways: ordered pairs, in a table, on a graph, or as an equation. Those are the different ways that we can take two different variables, an input and output, and show the relationship between them. So let's take a look at each of these really quick to see how it shows the relationship. So if we look at an equation, which we're used to, an equation simply relates two different variables together. Usually the x we call the input and y we call the output. So this is saying that if I input something in for x, what is the related y value? Well, whatever x is, multiply it by 2 and subtract 3. So for instance, if I plug 4 in for x, 2 times 4 is 8, 8 minus 3 is 5. So the related y value to the x of 4 is a 5. So 4 is related to a y value of 5. So an equation is one way to show the relationship between the input and the output. Another way is to just show the pairs that are made from the equation. Here I've got a list of ordered pairs. -2 input is related to an output of -7. An input of 0 is related to an output of -3. An input of 2 is related to an output of 1. Okay, so it's just literally showing if I have an input of x, what is the output y? So it's showing how the x and the y, the input and the output, are related to each other. A table does nothing but do the ordered pairs arranged in a table format. So you see the column of x's and the column of y's. Again, what's the input of -2 related to? It's related to the output of -7. And we could go down that list to show that relation. Okay? It's the interaction between two variables, the input and the output. The last way to see or the relation between two variables is graphically. So what I have here is the equation down here, 2x minus 3, graphed on a coordinate plane. Now you've done graphing before, and the important piece to remember is that a graph is nothing more than a visual representation of the relationship between the input and the output. The input is the x, that's the horizontal axis. The output is the y, that's the vertical axis. So for instance, what does the input of 2 give as an output? Well, if I go to and then over to my y-axis, that's a 1. So an input of x equals 2 goes up and over to an output of 1. So 2, an x input of 2 is related to a y input of 1, or a y output of 1. So now that we have an idea of what a relation is, we need to talk about this word called function. It's a word that you've used before, and it's been defined before for you, but we need to remind ourselves of what it is. So a function, simply put, is a relation. So it's the interaction between two variables, an input and output. So it's a relation. However, there's a stipulation put on it, in which each input leads to a unique output. Another way of saying that is every input leads to only one output, or every x leads to only one y value. So the three different ways that we're going to take a look at it and determine whether a relation is a function is through a table, and then ordered pairs, graph, and equation. Okay, let's start with tables. I've got 4 different tables here. Each table represents the relation between an input and an output. Input, output, input, output, input, output. And we can keep going on that. The question is, is this a relation, which is the interaction between an input and output? Is this relation a function? So we have to ask ourselves, does every input go to only one output? And in this case, I think, yes, it's true. The input of 1 only goes to -7. The input of 2 only goes to -5. The input of 3 only goes to -3. The input of 4 only goes to -1, and so on and so forth. Okay? So we would say, yes, this is a function. It's a relation in which each input leads to only one output. Now, what about this next table right here? Does each input lead to a unique or one and only output? I actually got a couple issues in this one. I see the input of 2 leads to the output of 13, but the same input of 2 in another case leads to an output of 3. I've got two different outputs associated with the same exact input. In one situation, the input of 2 leads to 13. In another situation, the input of 2 leads to 3. You can see that there's another issue here, the 3, -5, and 3, 5. In one instance, the 3 goes to a -5. In another instance, the 3 goes to a +5. This is not a function. Okay. Well, let's look at this next one here. -5, -3, 0, 6 to 3. Now, looks like this. Every input goes to a unique output. Now, some of you might be looking at this and saying, well, 6 goes to 1, 2 goes to 1, 3 goes to 1. I've got 3 different inputs that go to the same output. That's okay. Take a look at what it says up here. It's each input leads to only one output. I can have multiple inputs leading to the same output. What I can't have is the same input leading to multiple outputs. You're looking from X to Y. So in this case, this is a function still. And lastly, over here, what do we have? Let's see, I don't see any situation, -2, -1, 0, 1, 2, 3. I don't see any scenario in which an input leads to more than one output. So this is a function. In the context of ordered pairs, we look at it identically as we did with the table of data. Okay? And we simply ask ourselves again, is there any input that leads to more than one output? So let's look at this first case right here. I see a scenario, I see an issue here. I see that 6 in one case leads to -7, 6 in another case leads to -5. Therefore, this is not a function because I have one input, the value of 6, leading to two different outputs. That does not satisfy the definition of a function. What about this next one here? I don't see any repeating inputs, so there's no chance for it to have any input leading to multiple outputs. So this one is a function. Next, let's see, do we have any situations here? Ooh, I see a -3 and a -3. Each come from a different input. But on the previous slide, what we said was that's okay. We're not looking from output back to input. We're looking for input to the output. It is okay for two completely different inputs to go to the same output. That's fine. It's when it's the same input goes to two completely different outputs. So we're going to say that this is still a function. And lastly here, I think we're still a function here because I don't see any inputs here that go to multiple outputs. So we are still a function here. So the last context in which we want to look at this thing called function is in the context of a graph. I've got 5 different graphs here that we want to take a look at and determine which are functions and which aren't functions. Now you may remember from Algebra 1, something called the vertical line test. The vertical line test. The vertical line test says this: take a vertical line, and I could move this vertical line left and right. And I ask myself the question, is there any place that I could draw a vertical line that would touch the graph in more than one location? And in this first graph right here, no, I can't think of any vertical line that would cross my graph right here more than once. As I move the vertical line, it just simply shifts down where that vertical line is touching that graph, but it never touches the graph more than once. So we're going to say that this is a function. Let's go down to here though and look at the circle. A vertical line. Okay, I just drew a vertical line, and look at that. That vertical line actually touches my graph in 2 different locations. The question is, so this is not a function because it doesn't pass the vertical line test. The question is, why does the vertical line test work? Remember that your x-axis here is the horizontal axis and your vertical axis is the y-axis. So the x-axis is your inputs. So we can think of an input right here at 3. And then we go up to the graph and over, down to the graph and over. I have one input of x equals 3 leading to 2 different y outputs. One up here and one down here. So one input leading to 2 different outputs. That does not satisfy the function or the definition of a function. Okay, so let's look at the other ones really quick. Let's look at this one up here, the top right. This is a parabola, what you get when you graph a quadratic. Is there any location I can draw a vertical line that would touch that graph more than once? The answer is no. Well, couldn't I draw a line like this and it touches the graph more than once? That is true, however, it's not the horizontal line test, it is the vertical line test. And there is no vertical line that will touch the graph more than once at any given location. So this is a function. Look at this one down here that looks like a parabola on its side. And we can tell pretty quickly, there's a vertical line, and it's touching the graph in multiple locations. So the one input here at x leads to 2 different outputs for y. So this is not a function. Lastly, I have the graph of a vertical line. Can I draw a vertical line that touches the vertical line more than once? Well, interestingly enough, a vertical line is the worst offender because I can draw a vertical line right on top of it, and it doesn't just touch at more than one spot, it touches at an infinite number of spots. So a vertical line absolutely is not a function.